So I've got the power supply out again, originally to do some more testing and coding with a Raspberry Pi Pico and a ESP32 Wi-Fi, the Adafruit Airlift. But while there, I thought I'd explore this supply more. So there was a viewer question about the output stability, and we can put it through an oscilloscope and see what with and without load we get and see what happens. And also these front connections have got what appears to be an earth terminal and this lug that I mentioned towards the end of the last video. So we should see if these really do connect to earth, and maybe we can go and check things out. I recommend seeing the previous video on this supply if you've not done so. We're going to start with the earth lugs, and this is easy with a multimeter. So if I pop this meter into continuity mode, and I can tap the ends together to make sure it's good. And I'm sure you can hear the beep, and that is basically, that's my habit with this. Okay, so if I'm right about this, the green terminal here, there, should be power or not power connected through to the IEC plugs to earth here, which is this middle plug. Google can check that out, but here we go. There we go, it's connected through. Right, that's cool. Now, the other thing I want to do is, I suppose I also don't connect that ground or voltage to be connected through to anything here. So I'm going to put this in the ground here, and I'm just going to check that none of these pins connect to ground. None of them should. All good. And we should find the same with the voltage. That should not connect to any of these pins either, because those are all going to be DC and they're not going to be referenced to earth at all. So if we wanted to have our earth mains reference, which is what we've now got, as ground, we'd have to put a nice thick bar between the two. But wait, that's silver metal lug. At the end of the video last time, I just noticed this and said maybe there's an earth lug, and maybe this is for where you don't have an earth mains reference here. I don't know when you want to earth a chassis. So if I pop that there again into the earth there and tap this silver part of the screw, which one is it? It's not that side. Hold on, where I've lost it. Is it the other side? Where is it? I've lost the it is here. It's this one here. Look there. Right, okay, pop this in here, and this is slightly tricky. Okay, and if I use, okay, so that is connected through to earth. Okay, well, there we go. So we know that this can be used as an earth reference like I deduced before. So you could use that to say earth the chassis if this was on a rack or something. And you can use that to say bias, well, either side to earth mains reference. It doesn't matter because these will be floating otherwise. Cool. Okay, so I got the thing crudely connected to an oscilloscope probe. It's probably a terrible way to do it, but it'll work. And we're going to see how things look. So first I'll power it on. Well, let's not hit the output button. So I'll power that up. I was not expecting that. Why is there anything at all here? You all saw that, didn't you? Hold on then, let's just use our cursors. Let's just see, we've got, so if I, cursor A is 2.7 volts. We got a 2.7 volt spike. Really? Is this... Well, actually, hold on. Output's not even on this. So it's clear now there's no output, but during the moment when I turned it on, what was all that? So if I take cursor A down here, we're on what? Minus 2.21 volts. Cursor B. So we've got about a 5 volt difference there. Again, bear in mind actually that if this was Earth main reference, we might get something slightly different, but I must admit, I am not expecting that. Can I repeat that? Let's turn this off. And we'll just try that again, I guess. Right, we've cleared the scope. Turn it on. It didn't trigger that time. Okay, well, where's my trigger? At the moment, oh, my trigger's all the way up there. Let's put the trigger about there. Well, okay, we're seeing a lot of noise anyway for a power supply that's not got the output light on. So let's bring the trigger to about what? Okay, we'll call it 2 volts. So that's trigger at 2 volts. We'll power it off. Let's try turning it on again. It's waiting. There's my spike, turning it on again. It's set to 5 volts. That spike is nearly 10 volts. Let's turn it off. It's waiting again. We've got 5 volts this time. So we're seeing a spike every time we turn it on, whether the output is on or off. That's not great. And if I wind the wick down on this, so this is say down at what, let's try putting that at 1 volt, right? Imagine I'm doing some device that only deals with 1 volt. Okay, and then I turn it off. And let's put the trigger at, say, okay, 96 millivolts. So if it goes above that, we destroy our 1 volt device. So we got a 3 volt difference there, I guess. Yeah, look at that. That's more than nearly 10 volt difference. Just make sure the level. Okay. Turn it off. I'm pretty concerned about that. That big old spike. I mean, how long is that for? You see, you got spike and ringing, and I haven't turned the output on. So I'm glad someone got to plug this in. This is without me saying any output. This is without any load. And a low load condition is, I suppose, unusual. But there shouldn't be anything on those terminals when I turn it on. I mean, that's a bit strange. I mean, I don't know. I didn't expect that. All right, let's turn the output on and see what happens next. So I'll bring this up to, I've say, if I put this now up to 5 volts, which is where I normally have things. Okay. And I'll bring this up to, let's say, 4.8 volts. I'll sort of bring that down then. 4.8 volts, okay. So we'll turn it on and see, we should trigger it there. I mean, that's not so bad. There's still some noise. So if I just bring that down to the middle, we do have noise and ripple here. And at the moment I am triggering on events. Oh. Did we see some big spikes? I mean, we're saying 1 volt per division, so it's not going above 1 volt, but it's still not great. And again, this is showing 0 current, which may be because we're under no load conditions, that it's kind of not quite behaving correctly. It's not what I expected. What about when I turn it off? Turn off the power output. Maybe what I should do is I'll tell you what I'll do. let's change the timer. And let's do auto. Means it will just keep on sweeping. Okay, right, we've got this on auto. We're going to bring the scale up a bit. So this is on. And I'll just put this so if I press it, that'll zero it. There we go, we're at 5 volts with 2 volts per division, so there's 0. So if I turn it off, and we'll scale out a little bit. That's what I want. Okay, turn it on, turn it off now. That is taking a very long time to drop off. Yeah, we're there now. That was dreadful. Turn it on. Well, I saw that curve. You saw that curve. I didn't have it free on a one shot, so we kind of saw it curve and disappear. But when we turned it off, there's obviously some kind of capacitor draining out. And again, there's no load, so these are no load conditions. Should we see what happens with the load? Let's see what happens with the load. So the load we're going to use today, this is a Raspberry Pi Pico. It's got a bit of code that's actually doing a simple counter that will come out on this airlift. Most of the load is going to be the airlift, not this, and that's like an ESP32 Wi-Fi servery thingy. And when the light LED comes on here, it's ready for me to hit with a web page thingy. Okay, right, so this connects to voltage, this connects to ground. Let's go connect it up and see what happens. So power is connected there, as in positive and ground. Positive down here, it goes through a diode, which actually goes into the Pico, and there's a ground rail up the top here. Got the ground of the probe connected, and I've actually used the leg of this diode. It's a Schottky diode, and that's being used to probe the voltage. So 5 volts still, but we'll see the load. So we hit the output, and we've got a fair load happening. I didn't even watch the scope, so I didn't even see what happened. We're not seeing an awful lot of ripple here, which is kind of nice. I mean, let's just take that and zoom in a bit. Ooh. Hold on, that's not what I meant. So we should be able to see anything on there if we just bring it across to 0. There is some ripple, but it's not horrendous. I mean, we're now at 500 millivolts, and it's not going outside 500 millivolts here. Although Vmax, it's saying 5.14 as opposed to the 5, so yeah, maybe, but 14. Yeah, it's acceptable, but I want to see what happens when we turn it off. So when we turn it off, we're going to see that slow, terrible drop. I'll just scale back out to 2 and center that. There we go. Let's see what happens when I turn it off. That was visibly quicker. Okay, and I think what we'll do for turning it on, we'll make sure the trigger again, we'll put the trigger at here about 1 volt, and we'll put it on a single shot, which should give us a capture of that rise. There we go. So if we've got, what is this, 10 milliseconds, is that per division? That should be per division, I guess. If that's per division, it's at 10, 20, 30, 40, 50, 60, 70 milliseconds, 80, 90. So about 100 milliseconds is where we get to running. I'm assuming that's how you read this. Yes, I'm still there on the oscilloscope. Wonderful. There's quite a bit of rise time there, but there's not actually a lot of ringing after that, which is quite good. It's just this rise time is a bit on the slow side. I mean, it's not as slow as the full time. So if I then take our triggering to, say, 4.8 volts and turn the output off, Oh, it didn't actually trigger it. Oh no, I've got to hit the single shot button again. Hold on. Again, need to be better at using the scope. Need more practice. So I'm practicing right here and right now in front of you guys. And turn it off. And there's the down curve. Can I zoom out to see the whole down curve? We can. Does that mean... Is that meaning it's 200 milliseconds to turn off? Well, off is down at 0, so it didn't reach 0 in that time either. So that's me turning it off, and the curve flattens out, and I presume that flattening out is a capacitor discharging. So I'm not seeing a lot of ringing, but I guess I'm not entirely overly happy with the discharge time. We're only talking 100 milliamps anyway. It's the actual current draw for this device. But what I'm most concerned about with this is that power on spike. That to me is just unacceptable. So we'll go pop this again at what, 400 or 500. Hit the run stop. I'll turn it off. Nothing when I turn it off, but when I turn it on, we didn't get a spike then. Interesting. Is that because I'm too far zoomed out? Try that again. Maybe that's just a no load characteristic. Isn't that interesting? So if I was to take the load out like this, so I've taken the load out, bypass the load, turn it off, and turn it on again. Oh, hold on, got to hit the run button. Second, it's waiting. No load, turn it on. I'm not seeing those same dreadful spikes. That's interesting. That's interesting because the main thing that's now happening in this, now I've taken away the load, is I've got a long ground lead and a long positive lead, which I suppose is a little extra capacitance and a little extra resistance going across to the scope probes, but it shouldn't mean enough to change that spike. If I put them back, do we get the same spike? Okay, we'll prime the oscilloscope and hold on, we will turn it on. I have basically put the probes straight across again, and I power it on. See, now I'm out fishing for it. So I had this set earlier to 1 volt, or 880 volts, right? It's triggered it. But it's not enough to be a horrific problem here. What has changed? Nothing has changed. I've reconnected it as it was at the beginning. That's terribly frustrating. Well, anyway, we've seen some of this. We've seen there's not much ringing. We've seen there's a slightly dodgy startup without the output. We've seen that the output itself is a little on the slow side, but not dreadful. Hold on then. Let's see if we're triggering. Oh, well, it's not going to output anything yet. Hold on. That was me waving the probe in the air because I disconnected it. Hold on. I mean, looking at what happened there when I started disconnecting things and the scope kind of did that, I'm wondering if I had my ground connection here when I had it connected across to the probe was slightly iffy, and it was just picking up some stray voltage some transient voltage or whatever elsewhere. I mean, that was very strange, that behavior, and the fact that I wasn't able to reproduce it when I short the probes back, that was interesting in itself. I am unable to reproduce that same effect. So we launch that, launch this. Oh, look. So it's dreadful when, of course, ground is just plain not connected, but it doesn't explain what I saw earlier, unless it wasn't quite connected. Okay, but anyway, we've seen that the voltage rise, not too bad, not too much ringing. We've seen that the voltage fall when it's turned off is a bit on the slow side. A thing I wanted to do, but not with this load, was seeing what happens when we wind the wick up somewhat. So I am going to try, again, no load. Maybe I could put a resistor load on later. If there's appetite for that, we can try that. But I'm just going to do, again, just short this load, put this back into, do the sweep on auto, make it run. We're going to turn the output on. Should have us at 5 volts there. And I'm just going to scale us in so we can. Okay, now if I wind the wick up to 9 volts, I mean, it's not dreadful. It's quite responsive, isn't it? So I'm at 8.4. Now, actually, if I remember, there's a good way to do this. So I'll put that down to 0. And then I can do 9, 4. Okay, so it takes a while to go down. Takes a lot less time to go up. 8 volts, 5 volts. Again, I'm not seeing an awful lot of ringing. And okay, 6 volts, 7, 5. 6 is distinctly more noisy than 5 is. Is that the same true of all the higher voltages? That it's more stable at lower voltages? If I bring this down to 1, and it takes about a year to reach it. Well, there's some background noise on all of it, but oh, and it's forgotten I was on that digit. That's interesting. If you stop fiddling with it, it forgets. So throughout the video, I have been working mostly on controlling the voltage. I don't really have much call in my lab for constant current, but I could cover this in a follow-up video if there's an appetite for it, perhaps with a string of LEDs. Comment below if you'd like to see that. We could even try a big old LED strip for putting the larger current load on the supply and see how it copes. I hope you've enjoyed this video and learned a bit more about this NANKADF power supply. Go make stuff and be awesome. Bye. I'll turn it on. So there's no load. That should be a 5 volt potential. Oh, wait. Oh. Right, well, that's for the outtakes. I don't know how to use a scope.